finish up. So if you guys want to flip to the back side of the notes now. Oh, squeaky shoes now. All right. So we're looking at this drawing here. And so I want to talk to you guys about, like, this is just an example. Obviously, like, every drawing is different. I want to talk about things we can assume in this drawing and what we can't assume. And that kind of takes us through these postulates on the back side, or the side before. Just kind of understanding, like, I look at this drawing, and there's things I can definitely assume in this drawing, and then there's things I can't assume. So, and some of these are going to seem really obvious to state these, and you're going to be like, why are you pointing that out? And then others of them, you might be like, I don't know why I can't know that. So, does anyone want to tell me something they know about this drawing? What do you see in this drawing that you'd be able to tell me something about it? Yeah?
Not all the lines are on the plane.
So all the lines are on that plane. So the fact that those lines are all like drawn on that plane, we can assume that. So, and what do we know about the dots then too on there? Are there any dots that aren't on this plane? So these are all coplanar points. So we can assume that. So all the points and the lines are all on that plane. Anyone have other things that they can tell from this drawing? And it's kind of weird to tell because it's like kind of, some of them are so obvious that. So some of the things I see are, so if points are on the same line, they're collinear. So I see collinear points as well. However, not all the points are collinear. So like points I see that are collinear are on the same line. However, you cannot assume points, you cannot assume they're collinear if they do not share a line. And I'll show you guys what I mean. So I guess I'm going to alter this. So collinear points on the same line. So to me, so GFE, this is an example of points that are actually, I can't assume those are collinear. They kind of look like they do, right? Doesn't it look like G, F, and E would be on the same line? You see where those are, kind of across the bottom? It kind of looks like if I drew a line through them, they should be collinear. We can't assume that. So you cannot assume they're collinear if they don't share a line. So G, F, and E, I would not say that those are collinear. I'm going to write that under here, non-collinear. So we have to have a line through them to kind of show us that that works. You want a filled out one? No. Okay. Oh. Okay. All right, the next thing. Do you remember what kind of angles we can assume are equal? What kind of angles can we assume are equal in this drawing? They have a name for them. What type of angles can we assume are equal? Starts with a V. Yeah, Michael?
Vertical angles.
Vertical angles. So you can assume vertical angles are equal. So I use the little symbol, angles equal. Vertical angles are equal. Now you cannot assume you can't assume angles that just look equal are. So you cannot assume that angles that look equal are equal. So like in this drawing, like if you look and you're like, well, I kind of think the angle by H and the angle by J look equal. We don't know that for sure. So we can't just say that I think that those two are equal. So vertical angles are, but we can't assume if they just look equal, they are. Another thing we can assume is a linear pair or a straight angle. You can assume a linear pair or straight angle. So if it looks like a straight line, you can assume it's a straight line. Now you cannot assume a right angle. So just because something looks like a right angle does not mean you can assume it is. It's got to have some sort of mark for you. Same thing with parallel lines. You can't assume lines are parallel. So just because lines look parallel, we can't assume they are. And finally, the last thing that we can assume is we can assume that lines that look like they intersect do. So I don't have to tell you that two lines intersect if it looks like they will intersect. So we're going to do some true and false questions down in the bottom here. And then again, you guys will have the rest of the time to work on the homework once we do the true and false. We'll have these down. Okay. So can we assume, mine's really hard to see up here. Sorry, those of you guys online, you might have to look at the thing I emailed you guys. So can we assume that points A, B, C, and E are coplanar? A, B, C, and E. Yeah, you think so? Yep, so they're all on this, the plane that's like kind of horizontal, so that would be true. B, F, and G are collinear. B, F, G, collinear. Nope, there's no line through them. Do you remember what that upside down T symbol means? Perpendicular. So don't forget about that. So that little upside down T means perpendicular, which also means like a 90-degree intersection, right? So it says HC is perpendicular to GE. HC is perpendicular to GE. So HC is this one. GE is this one. Are those perpendicular? What tells us they are? They look perpendicular, but there's something that tells us. Yeah, Dawson? The little square. That little square shows us that they are perpendicular. And again, you can assume then all the corners would be 90 degrees, so this one is true. EC intersects plane M at point C. So EC is a line, intersects plane M, which is, so EC is this one. Here's plane M. Where does that line hit that plane at point C? You guys agree with that? Yeah, looks good. And then the two planes intersect at line BC. So the two planes intersect at this line here, so that is also true. So homework is listed there for you guys. It is 2 different pages. I did upload the whole thing like in Schoology, so you might just scan down a couple times to get to the different pages where the homework is. But but do notice it's 2 different pages, so it's a little bit on the longer side, give you guys some time to work on it. Yeah, so let me know if you guys have questions at all.